Okay, so yesterday, remember, we talked about lots of equations. So we're going to probably do only two more and move on to the next thing. Okay, because we got two more smaller things to talk about. So remember yesterday we talked about basic equation is a times b to the x. A is your starting point, b is what you multiply by. So we talked about you and the bacteria in your feet. Okay, that was 15 times 2 to the x. We talked about what if there were 4 bacteria and they triple every hour. That was 4 times 3 to the x, and that got really big. Then we talked about you being a delinquent and bouncing a basketball off the top of the water tower. Not recommended. But it bounces back as half its height, so 200 times 0.5 to the x power. Now, most of the time, this is where we spent most of our time yesterday, we deal with percents in our exponential equations. So a is still the starting point, but it's 1 plus or minus r written, and r is the percent written as a decimal. How do you know if it's plus? So if I give you let me ask the question better. If I gave you a story problem situation, how do you know whether you're supposed to put plus or you're supposed to put minus?
If it grows
or if it something that's going the plus, if it's something that's going down, you put the minus. So we talked about the population of Fremont that grows. So that was plus 0.012, and it went up, and the population decreases at 2% a year. That was the minus. Okay, we purchased the Mona Lisa, which was not realistic, and then we talked about your current salary. Okay, your current salary and the 5% raise. So let's do two more of these, and then we will move on to our last couple of things that we need to talk about. Okay, I'm running out of things. Okay, here you go. This one's real life for people. Do you guys know that when you go and if you were to go to a car dealership and buy a brand new car, okay, first of all, it's a lot of money. Second of all, as soon as you drive it off the parking lot, do you know what happens to its value? It goes down. That's something called depreciating, okay? Losing value. That's real life, you guys. Your car, everybody's car, loses value every year. The only time that turns around is if you get cars that are classic cars. You guys know what I mean by classic car? Like you see somebody with a super cool car. If somebody takes care of that and I can't think of it. They refurbish it and they do all that stuff, then its value will go up. But that doesn't usually happen, right, Trina? Why are you talking? Okay. So with all of your money from your $60,000 a year salary, 25 years later, you got a lot of money, so you can buy a car. So let's say you buy a car, new car. We're going to say your new car costs $45,000.
That's not a GTPS.
Okay. It is not. Thank you, Charlie. So you buy a new car, for $45,000. Now, this guy loses value. Sorry, I'm having trouble writing. I didn't even have coffee today. Loses value at 7% a year. Okay, so your new car, $45,000, loses value at about 7% a year. I would like you to write that equation for me, please. Okay, so y equals what?
45,000 parentheses 0.53
0.93
parentheses to the x number.
correct. Okay, now that's correct. So let's talk about where did the 0.93 come from? Yes. Okay. So 1 minus 0.07. So we know that it's 1 plus or minus r. This case, it's minus because we're talking about losing value, right? It loses value at 7%, and the 7% is 0.07. So we talked about that yesterday. 7%, 2 decimal swoops to the left, 0.07. Or divide by 100. So if you cannot remember that it's 2, just do 7 divided by 100. That will also get you the 0.07. Okay. And then 0.93 is the thing that I want you to be using to put in your calculator. It's easier, less chances of retyping. Typing it wrong, I mean. Okay, so let's say then, this is your situation. When your car is 5 years old, how much is it worth? Okay, so let's say you're like, it's 5 years old. I'd like to trade it in, or I'd like to sell it to someone. How much is it worth? $306, essentially, yeah. Okay, so it's $31,305.97. So essentially $31,000. Okay, still not bad if you want to sell your car. Then let's go for 10 years old. I think that I'm looking at these numbers, it's probably more than 7%. 21,799, right? It's $21,800 essentially. Still pretty good. Like I said, I think it's probably more than 7%.
It's 79, not 90.
Thank you. Okay. Do you have what? Yeah, in the right hand side. On the top shelf. Okay, last one of these. Let's say that we have what are you gonna do? Nope. Okay, so you guys ever get fruit at your house and then all of a sudden fruit flies magically appear? Yeah, I hate those things. They're annoying. I don't know where they come from, honestly. So let's say that you are studying this in the lab. Where do those fruit flies come from? And so you're a scientist studying fruit flies. Boring, frankly, but whatever. You start out with 20 fruit flies, and you realize that fruit fly population increases by 12% every day. Okay? The FF is fruit flies, by the way. So a population of fruit flies, you have 20 of them, and it increases at 12% every day. Okay, please write the equation for me. I want you to hear me again. I want you guys to do as well as you can on your quiz that's on Friday. Make sure that you put y equals when you write an equation, okay? Don't just write the numbers because I will take points off. You don't want that. No. Divided by 100, Abby. Okay, y equals what?
20 parentheses 1.12 to the x power.
Yep. Okay, the point 1.12 is 1 plus 12 divided by 100. 12 divided by 100 is 0.12. Okay, I don't really, this is every day. Let's say how many fruit flies after 1 week? Okay, how many fruit flies after 1 week in your lab?
So that makes it a 7.
44 fruit flies. Okay, because you got to watch what's going on here. 1.12. If our fruit flies are going every day and I ask you for a week, what number do you put in for X? 7. Yep, your timing is terrible. Okay, so we are going to move on a little bit. So still related, but we're going to kind of go backwards. So let's say I give you an equation. I'm just going to give you an equation. I'm not going to take the time to give you a story to go with it. Okay, so you need to be able to look at this equation and tell 2 things. You need to be able to tell me if it's exponential growth or exponential decay. And then you need to be able to tell me what the percent was. Okay, so just like that's one of the reasons that we've been writing it like this, right? So I can look at this one and go, is it exponential growth or exponential decay? This one, because what's true about that number? It's more than 1. It's more than 1. So it's exponential growth. I know that it's 12% because that's that number there. Okay, so here, exponential growth or exponential decay? Growth. Okay, and the reason why, just in case you didn't hear me the last time, 1.04 is more than 1. So if we have a number that's more than 1, it's exponential growth. Now, what percent did it grow by?
1.0.
Okay, so we know if we take it backwards, this is 1 plus 0.04, right? What percent is 0.04? 4%. Okay, so the way that you get that is you either take your 0.04 and you move him 2 decimal places back to the right, or you take your 0.04 and you times him by 100. So you undo the work that somebody already did. Okay, so let's say we have 50 and 1.25 to the x power. Okay, are we looking at exponential growth or exponential decay? It's growth. Okay, what percent? 25. 25%. Okay, let's say of 100 and 1.034 to the x. Okay, are we looking at growth or decay?
Growth.
Growth. Okay, what is our percent? 3.4. 3.4%. Okay, so y equals 12 times 0.95 to the x. Okay, growth or decay? Decay, because this number is less than 1. Now, it's a little bit harder to figure out this. It's not terrible, but it's a little bit. What percent?
95.
So here's the probably the I don't know what way. Okay, it had to be 1 minus something and it got 0.95. So there's one way to think about it. Close. Or you can think about it this way. This is currently 95%, right? How much was taken away from the whole? There you go. Okay. 5%. I think that's probably the easiest way. Okay, it's supposed to be, you want it to be 100%. This is 95%. That means 5% got taken away. Okay, so it's really easy to tell the percent growth for exponential growth. Exponential decay, you're going to look at what percent did we take out. Okay, so this is 95%. What percent was removed? So let's go 50 times 0.75 to the x. Okay, is it exponential growth or exponential decay? It's decay. Now, I'm going to talk you through this one. What percent is this right now? 75%. 75%. So how much was taken out if I have 75%? 25%. So that's how much was removed. 25%. We'll do one more example after this one and then move on to our last thing. Okay, so exponential growth or exponential decay? Growth. I'm trying to trick you there. Okay. What percent growth? That's what it is. It looks like 150. So how much over 100% is it? 50%. Okay. Because how much over, right? It's how much above or below the 100%. And then last one, let's do 500 times 0.3 to the x power. 500 times 0.3 to the x power. Okay. Growth or decay? Oh, it's decay because this number is less than 1. Okay, number's less than 1. Now, what percent is right here? 30%. This is 30%. How much was taken off?
70%.
Okay. So this is, you're looking at percent added here and percent removed here. Okay, percent added, percent removed. Now, the last thing we need to be able to do, we did this on our warm up, but I want to talk to you, told you I would tell you about this. We're going to ask the question, is this exponential growth? We're working with tables now. Sorry, I should have said that. Exponential growth, exponential decay, linear, or none of those. Okay, so we're going to talk about how do you make an informed decision. Okay, there you go. We got a lot of decimals on this one. So here's my thought to you. First of all, is this going up or going down? It's some kind of growth. We need to decide if it's linear or exponential or neither, but we do know that it's exponential, that it's not exponential. We don't know yet, that it's growth, right? We know that it's growth because it's going up. Okay, that's pretty easy. You go, hey, it's going up. But what we have to be able to do to decide if it's exponential, we need to figure out, is it multiplied by the same number every time? Okay, so that's the question that we're going to answer. Is it multiplied by the same number every time? And it's kind of weird, you guys, because to figure out if it's been multiplied, we actually have to divide it. Okay, so when I talked to you about exponentials, I said it's never made by dividing, but we uncover its multiplication by dividing. It's kind of seems a little bit backwards. But what you do is you take your number, you take the last number in your thing, and you divide by the number in front. Okay, so we're going to do 39.0625. And we're going to divide them by 15.625. Okay, what do you get when you do that? You get 2.5. Then you're going to repeat. You're going to take this guy and you're going to divide by the number in front of him. So you're going to repeat that and see what you get. What do you get? You get 2.5. And then you do it one more time and see if you get 2.5, because those have to be all the same to be exponential growth or exponential decay. Okay, just a second. So let me finish my thought and then I'll happily listen to you. This is also 2.5. 6.25 divided by 2.5 is 2.5. So these are all the same. And so that means if it's multiplied by that, that means it's exponential. And you can say, hey, I'm multiplying by 2.5, so it must be exponential growth. Or you can say, look, it goes up. It's growth. Okay, because it goes up. Yes, McKinley, go ahead.
So if we figure out like what it's multiplying by, can we just multiply like 2.5?
But then you could do the next one. You could go backwards. Once you figure, you could do what McKinley said also. Once you are like, hey, this is 2.5, you can start here and multiply by 2.5. Those are 8th graders. Case? Okay. So let's try this one. Okay. Let's say we have 1, 2, 3, 4. This is going to be 80, 64, 51.2, 40.96. Okay, I would like to know exponential growth, exponential decay, or linear, or none of those. Okay, so pick any pair. It doesn't matter which pair you pick if you want to do what McKinley said. Okay, but it's always the second number. So the further down number, I don't know, it's not be the last one, but one number has to be divided by the number before it. So you cannot start with 80. You gotta start with 64 and divide by 80, or 51.2 and divide by 64, or 40.96 divided by 51.2. Okay, when you divide this, what do you get?
0.8.
You get 0.8. Do you get 0.8 every time? Yes. So if this is 0.8, that's less than 1. So it's what? Exponential decay. Okay, and that's because you're multiplying by a number less than 1. Or you could say, I multiply by 0.8 every time and it's going down. So it's decay. We're talking about the reasons because on your test and quiz, I'm pretty sure you have to say the reason. Okay, let's try this one. Okay, exponential degrowth, exponential degrowth, exponential growth, exponential decay, linear, or none of those. You guys are holding it together really well for me today. I really appreciate you. 7th hour's gone way off the rails, so I'm thankful for you guys today. You think?
It's because Levi's in that class.
Oh, he's so much trouble, Charlie.
I bet.
Don't take me off the rails. I just got done saying that I was really thankful for you all today. Don't destroy it. Hi, Liam. Hey, exponential growth, exponential decay, linear, or none of those?
Growth.
Linear.
It's linear. Okay, why is it linear?
Because it's growing by 5.
Plus 5. So listen, if you just do this, if you just take 25 divided by 20, you're going to, and you can divide that, but then the other ones don't divide. So that's true. Like it doesn't divide. So you're going to be like, oh, that's none. But don't forget to check for linear. This is plus 5 every time. Okay, and we talked about that a couple days ago. Linear is formed by adding or subtracting. So this is plus 5. Okay, try this one. What? What really necessary? Well, that's annoying. Why? Why would you destroy the good feelings that your teacher has for the whole class? Baloney.
Send him to the home.
Where's he headed?
Not the middle school. That's a bad idea.
No, it would just be the office. Skip the hall.
That's a good idea.
Thanks for your approval.
You're welcome.
Okay, linear.
All opinions go for me.
Owen. Linear. Neither. Exponential growth, exponential decay. I don't know why they had to be out of order that time.
Neither is exponential growth.
So it can't be both.
I'm feeling expert. Neither.
Okay, so let's divide. Right, what's 120 divided by 100?
1.4. Wait, 2.
1.2. Okay. Let's let's look at this. What's 156 divided by 120? 1.3. So right now I can stop looking at exponential because those numbers are not the same. It's not exponential then. Now let's look at linear. So if it was going to be linear, I would be doing what here? I would add 20. And if I was going to add 20 again, I would get what? 140, which it's not that either. Okay, so I know it's neither because it doesn't fit the pattern where I'm multiplying by the same number, and it doesn't fit that I'm adding the same number every time. So this is none. It's just nothing. Okay, so if when you divide, the numbers are all the same, you know it's exponential growth or exponential decay. If the number's less than 1, it's decay. If the number's greater than 1, it's growth. Okay, don't forget that linear is a thing. And we add the same number every time. Okay, so that was a lot of stuff today. So just a reminder, what we talked about, we reviewed our writing equations. We talked about figuring out if it's growth or decay by looking at our equation and how much does it go up or down by. And then we did the table thing. Okay, those are the things that will be on your homework. So your homework, which you have a nice amount of time to work on today.
Oh, that's it.
No,
You should totally just do that.
no. You're so funny. Did I say that?
Yeah.
That's not what I said. Your favorite class this hour?
That was a good one. Whoever said that.
There you go. Most of this is just you writing an equation. Okay? Most of it is just writing the equation. So it's going to be real quick. It's not stuff that is a lot of work. There you go. Okay, it's a pretty quick assignment. I know it seems like there's a lot of numbers, but we did a lot of things. Mostly it is writing equations that will not take you forever.
Yep.